एवरीवन, आज हम लोग डिस्कस करेंगे एनटीपीसी असिस्टेंट केमिस्ट ट्रेनी एग्जामिनेशन इलेक्ट्रोकेमिस्ट्री चैप्टर। ओके, सो ये चैप्टर हम लोग 2 वीडियो में कंप्लीट कर लेंगे। पहले हम लोग कंप्लीट करेंगे कंडक्टेंस ऑफ इलेक्ट्रोलाइट सॉल्यूशन। इलेक्ट्रोलाइट के 2 टाइप का होता है, ठीक है। एक है स्ट्रॉन्ग इलेक्ट्रोलाइट और एक है वीक इलेक्ट्रोलाइट। फॉर स्ट्रॉन्ग इलेक्ट्रोलाइट degree of dissociation, that is alpha, is high, and for weak electrolyte degree of dissociation alpha is low. और एक बात, फॉर इलेक्ट्रोलाइट सेल, फॉर इलेक्ट्रोलाइटिक सेल, इलेक्ट्रोलाइटिक सेल में कौन सा सेल? इलेक्ट्रोलाइटिक सेल, इलेक्ट्रिकल एनर्जी converted to chemical energy. Okay, here cathode एंड एनोड, कैथोड एंड एनोड, कैथोड में रिडक्शन होगा, एनोड में ऑक्सीडेशन। कैथोड इज नेगेटिवली चार्ज एंड एनोड इज पॉजिटिवली चार्ज. ओके, now we discuss about the all formulas. Okay, for Ohm's law we know V equals to IR. V equals to IR. Here V is volt. Okay, V is volt, I current, and R is resistance, potential, that is potential. Okay, now the units of V is volt and I ampere, and for R is ohm. Okay, now here we can write R equals to rho into L by A. R equals to rho into L by A. Okay, here L by A is called cell constant. L by A को cell constant बोला जाता है, ठीक है. And R is we know resistance. Okay, now rho is resistivity. Rho is resistivity. Here we can write 1 by rho equals to 1 by R into L by A. Okay, 1 by rho, that means resistivity. 1 by resistivity is called kappa, conductivity. Kappa conductivity equals to 1 by R. 1 by resistance equals to conductance. 1 by resistance equals to what is called conductance. Kappa equals to G into L by A. Okay, now what we say, what we can see, the unit of V is, we say volt, I is ampere, and R is ohm. So R equals to rho L by A. R is ohm. So rho equals to R into A by L equals to ohm into A is area semi square divided by semi equals to ohm semi, and kappa conductivity equals to ki? What is kappa? Kappa equals to 1 by rho. 1 by rho means 1 by ohm into semi. 1 by ohm means ohm minus ohm inverse and semi inverse. Okay, now ohm inverse is called Simon, that is we can write S into semi to the power minus 1. Okay, now G, what is G? Conductance equals to 1 by R, 1 by resistance, that means 1 by ohm equals to ki? Equals to ohm to the power minus 1 equals to Simon. Okay, now the next is molar conductance. Molar conductance lambda m equals to kappa into molar volume. Kappa, what is kappa? Kappa is conductivity. Kappa equals to 1 by rho, 1 by resistivity. We see here kappa equals to 1 by rho, that means 1 by resistivity. Okay, R is resistance, rho is resistivity, kappa is conductivity, G is conductance. Okay, lambda equals to kappa into Vm, or we can say lambda m equals to kappa by C. Here C is the concentration, mole per liter. Okay, mole per liter. Okay, now the unit of the unit of kappa is Simon per semi, and the unit of concentration is mole per liter. We know लीटर में लीटर को चेंज करना पड़ेगा, ठीक है. सो लीटर को हम क्या लिख सकते हैं? 1 लीटर इक्वल्स टू 100 सेमी क्यू. सो लीटर टू द पावर माइनस 1 को हम लोग लिख सकते हैं, क्या लिख सकते हैं? Simon semi to the power minus 1 by mole into semi to the power minus 3. dash means semi to the power minus 2, or the unit of lambda m equals to Simon semi square mole to the power minus 1. This is the unit of molar conductance. Okay. Now equivalent conductance, lambda equivalent equals to kappa by C equivalence. Now this concentration terms is in normality. Okay. Acha. Okay, as we know, normality equals to molarity into Z factor. What? Normality equals to molarity into Z factor. if molarity में given है concentration, सो उसको Z factor से मल्टीप्लाई कर लेंगे और हमको नॉर्मलिटी मिल जाएगा. ठीक है. नाउ what is the relation between molar conductance and equivalent conductance? So lambda m equals to Z factor into lambda equivalent. What's lambda molar conductance equals to Z factor into lambda equivalent. Here what is Z factor? Z factor is total number of positive or total number of negative charge. Total number of positive or negative charge. Okay. Okay, now if we plot the graph molar conductance versus concentration, then for weak electrolyte this is the graph, and for strong electrolyte this is the graph. What is this? Is for strong electrolyte and this is for weak electrolyte. Okay. Okay, now we take a weak electrolyte like HA, which dissociate into H plus A minus. Its degree of dissociation is low, so this is a reversible process. Okay, now the concentration of HA at a time equals to T, C00 at time equals to T, at a arbitrary time T, we write C minus alpha C, alpha C, alpha C. Alpha is the key. What is alpha? Alpha is the degree of dissociation. That means डिग्री ऑफ डिसोसिएशन मतलब क्या होता है, एक मोल से कितने मोल डिसोसिएट होता है वो है डिग्री ऑफ डिसोसिएशन. हाउ मेनी मोल्स डिसोसिएटेड पर मोल ऑफ इलेक्ट्रोलाइट. एक मोल से अगर अल्फा मोल डिसोसिएट करेगा, सी मोल से कितना डिसोसिएट करेगा, सी अल्फा, देन सी माइनस अल्फा सी, अल्फा सी, अल्फा सी इतना डिसोसिएट करेगा. तो सो ये अल्फा सी एंड अल्फा सी क्या होगा, ये प्रोडक्ट बनेगा. ओके, नाउ alpha is very low, and one more thing, alpha equals to lambda m by lambda naught m. What is lambda m? Lambda m is molar conductance. Okay, and lambda naught m is molar conductance at infinite dilution. Okay, alpha is degree of dissociation, its value is very low. So इधर ये है डिसोसिएशन कांस्टेंट और आयोनाइजेशन कांस्टेंट. के मीन्स एसिड, के ए इक्वल्स टू अल्फा सी इंटू अल्फा सी बाई सी माइनस अल्फा सी. सो होगा सी स्क्वायर अल्फा स्क्वायर बाई सी इंटू 1 माइनस अल्फा. सो सी अल्फा स्क्वायर इक्वल्स टू 1 माइनस अल्फा. अल्फा इज वेरी लो, so 1 minus alpha is approximately near 1. So we can write k equals to c alpha square. K equals to c alpha square. Okay, now pk equals to minus log of k. यहाँ से हम pk वैल्यू कैलकुलेट कर लेंगे. ठीक है. नाउ व्हाट इज अल्फा इक्वल्स रूट ओवर के ए बाई सी. अल्फा इक्वल्स रूट ओवर के बाई सी. के बाई सी अल्फा का वैल्यू इधर से कैलकुलेट कर लेंगे. अगर हम लोग को पी एच पूछा है, सो पी एच इक्वल्स टू माइनस लॉग ऑफ एच प्लस. एच प्लस का कॉन्सेंट्रेशन, एच प्लस का कॉन्सेंट्रेशन क्या है, देखो इधर अल्फा सी. एच प्लस इक्वल्स टू अल्फा सी. इधर से हम लोग क्या पी एच भी कैलकुलेट कर लेंगे. ठीक है. और के अगर के वैल्यू पता है, सो पी के का वैल्यू भी हम लोग कैलकुलेट कर लेंगे. ठीक है. ओके, नाउ वन मोर थिंग, 1 by lambda m equals to 1 by lambda naught m plus c lambda m by ka into lambda naught m square. If we plot 1 by lambda m for weak electrolyte, C lambda m, then the graph is look like this, y equals to mx plus c, this is c, intercept lambda naught m, and this is slope 1 by ka into lambda naught m square. Okay, now we discuss about Debye-Hückel-Onsager theory. What we discuss? Debye-Hückel-Onsager theory. What is Debye-Hückel-Onsager theory? Debye-Hückel-Onsager theory depends on two effects. One is asymmetric effect and one is electrophoretic effect. Asymmetric effect is due to ionic atmosphere and electrophoretic effect is due to hydrated sphere. Here the equation is lambda m equals to lambda naught m, okay, minus a lambda naught m plus b into root c. Here a equals to 1 by t depends on decrease due to asymmetric effect and b decrease due to electrophoretic effect. A equals to 1 by t and b equals to eta by t. Eta is viscosity. Here we can write proportional. Okay, now what is asymmetric effect and electrophoretic effect? Asymmetric effect means ये हमारा सॉल्यूशन है, इधर पॉजिटिव नेगेटिव इधर उधर प्रेजेंट रहेगा. अगर हम इलेक्ट्रिक फील्ड अप्लाई कर देंगे तो फिर क्या होगा, ये जो पॉजिटिवली चार्ज है ना, इसके अगल बगल में नेगेटिव चार्ज होगा. पॉजिटिव चार्ज के अगल बगल में नेगेटिव चार्ज होगा. ये है कैथोड एंड ये है एनोड. कैथोड इज नेगेटिवली चार्ज, एनोड इज पॉजिटिवली चार्ज. सो जो पॉजिटिव आयन है वो क्या करेगा, वो कैथोड में जाना चाहेगा, लेकिन और जो नेगेटिव चार्ज है वो एनोड में जाना चाहेगा. लेकिन इधर जो है, जो पॉजिटिव चार्ज के अगल बगल में एटमॉस्फेयर में नेगेटिव चार्ज है, सो ये चार्ज नेगेटिवली चार्ज पॉजिटिव चार्ज को खींच के रख देंगे. अगर खींच कर रख देंगे तो ये पॉजिटिव चार्ज कैसे कैथोड में जा पाएगा. ओके, so this is asymmetric effect. If we dilute this solution, then what happen, then positive negative सब दूर हो जाएंगे. उसके बाद अगर हम इलेक्ट्रिक फील्ड अप्लाई करेंगे, so this is anode, this is cathode, स्पीड इंक्रीज होगा एंड हमारा मोलर कॉन्डक्टेंस भी इंक्रीज करेगा. दिस इज एसिमेट्रिक इफेक्ट. एंड व्हाट इज इलेक्ट्रोफोरेटिक इफेक्ट? इलेक्ट्रोफोरेटिक इफेक्ट मीन्स सेम पॉजिटिवली चार्ज, इधर नेगेटिव चार्ज भी होगा, लेकिन इधर हाइड्रेटेड स्फीयर भी रहेगा. हाइड्रेटेड स्फीयर मीन्स एक पॉजिटिव चार्ज मैं लेती हूँ Na+, उसके अगल बगल में वाटर का ऑक्सीजन रहेगा, उसका अगल बगल में वाटर का ऑक्सीजन रहेगा. ओके, नाउ फॉर नेगेटिव चार्ज के अगल बगल में क्या होगा, हाइड्रोजन रहेगा. नेगेटिव चार्ज के अगल बगल में हाइड्रोजन रहेगा. ओके, इफ वी डाइल्यूट दिस सॉल्यूशन, इसका बीच एक एट्रैक्शन रहेगा ना, इसका बीच एक एट्रैक्शन रहेगा. इफ वी डाइल्यूट दिस सॉल्यूशन, सो क्या होगा, डाइल्यूशन इंक्रीज करने से इंटरेक्शन डिक्रीज करेगा, स्पीड इंक्रीज करेगा, मूवमेंट ऑफ आयन्स भी इंक्रीज करेंगे एंड मोलर कंडक्टेंस भी इंक्रीज करेंगे. ओके, सो दिस इक्वेशन इज कॉल्ड Debye-Hückel-Onsager इक्वेशन, वेयर A is constant, B is constant, A decrease due to asymmetric effect, B decrease due to electrophoretic effect. Lambda m equals to molar conductance of any concentration and lambda naught m equals to molar conductance at infinite dilution. Okay, now we discuss about Kohlrausch law. Kohlrausch law is for univalent electrolyte like NaCl, univalent electrolyte where Z factor equals to 1. Here we can write lambda m equals to lambda naught m minus b root c. Here b depends on stoichiometry and lambda naught m depends on specific identity of electrolyte. Okay, now if we write AXBY equals to XAY plus YBX minus, so the molar conductance at infinite dilution of this compound AXBY equals to what? x into ionic conductivity of positive ion and plus y into ionic conductivity of negative ion. Okay, for equivalent conductance it does not depend on the coefficient x or y. For lambda equivalent, lambda not equivalent equals to lambda equivalent into ay plus lambda equivalent into bx minus. Okay, now we are discussing about transport number. What is transport number? Transport number is fraction of total current carried by an ion. What is transport number? Fraction of total current carried by an ion. Higher the value of transport number, higher will be the speed of ion. Transport number का value जितना high होगा, ion का speed भी उतना high होगा. And one more thing, transport number always less than 1. Transport number is always less than 1. Okay, now the total transport number we can say t minus equals to 1. This is the transport number for cation, this is transport number for anion equals to 1. We can write t plus equals to I plus by I plus I minus equals to q plus by q plus q minus equals to v plus by v plus v minus or equals to mu plus by mu plus mu minus equals to 1 minus t minus. Okay, I is amp current, q charge, v speed, mu equals to ionic mobility. At infinite dilution, the compound AXBY at infinite dilution, again it dissociate XAY plus Y B X minus. Here the transport number equals to transport number for cation equals to X into ionic conductivity of A or Y plus cation and X into lambda ionic conductivity lambda m equals to A Y plus Y into ionic conductivity of B X minus, or we can say total conductivity of the compound. Okay, now we are discussing about ionic mobility. What is ionic mobility? Ionic mobility is speed of an ion under electric field. Ionic mobility is speed of an ion under electric field. इधर दो फॉर्मूला होता है, एक है म्यू प्लस इक्वल्स टू वी प्लस बाई स्पीड ऑफ आयन बाई पोटेंशियल ग्रेडियंट. What? Mu plus ionic mobility of cation equals to V plus by potential gradient. So V plus by del phi by L. What is del phi? Del phi means potential difference by length and speed. अच्छा, okay. Unit क्या होगा? Unit is what is the unit? This is semi per second divided by V length. What is length? Semi to the power minus 1, or we can say semi square v to the power minus 1 per second. Okay, और SI में क्या होगा? SI में होगा मीटर स्क्वायर v to the power minus 1 per second. Okay, now at infinite dilution, अगर infinite dilution होगा तो क्या लिख सकते हैं हम? mu naught plus equals to ionic conductivity of cation divided by Z plus mod value and F. Ionic conductivity of cation Z plus mod value है and F. F is charge on 1 mole of electron. What is F? Charge of 1 mole of electron. The value of F is 96500 coulomb per mole. 96500 coulomb per mole. Okay, now Z plus is charge on cation. Okay, now lambda ionic this is ionic conductivity of cation and this is ionic mobility of cation. Okay, now on the last formula for sparingly soluble salt we can write AgCl This is sparingly soluble salt, partially dissociated Ag plus Cl minus. Okay, now here the solubility is S. The solubility equals to S, and Ksp is the solubility product, equals to S into S equals to A square, as Ksp equals to Ag plus concentration into Cl minus concentration. Okay, so a concentration of AgCl equals to 1, as this is a solid. Now the solubility S equals to kappa of salt divided by lambda naught m into salt का molar conductance. Now this complete हो गया. कंडक्टेंस ऑफ इलेक्ट्रोलाइट सॉल्यूशन, इसका कुछ मैथ देख लेंगे फिर हो जाएगा. ठीक है. Now we discuss the question. A 0.5 molar solution has a resistance 25 ohm in a conductivity cell. The distance between two electrodes is 1.75 semi and the area of every electrode is 4.0 semi square. What is the conductivity of the solution? Okay, conductivity, that means कप्पा पूछा है, क्या है. अच्छा, ओके, गिवन C इक्वल्स टू कॉन्सेंट्रेशन इक्वल्स टू 0.5 molar, does not required here. Okay, and R equals to 25 ohm and L equals to 1.75 semi and A equals to 4.0 semi square. We know R equals to rho L by A, resistance equals to resistivity into cell constant, and 1 by rho equals to 1 by R into L by A, that is 1 by rho, 1 by resistivity, it's called conductivity, equals to 1 by resistance, 1 by R into L by A. Okay, then 1 by 25 into L means 1.75 by area 4. Now we calculate 7. That's mean. Okay, now the second question is, at 80 degrees Celsius in n by 10 KCl solution, the conductivity is 0.0112 Siemens per semi and resistance is 55 ohm. What is the cell constant of the cell? Cell constant mean L by A का value पूछा है, R का value given है, R equals to 55 ohm and K equals to 0.0112 Siemens per semi. Okay, we know R equals to rho L by A, or 1 by R equals to, 1 by rho equals to 1 by R into L by A, or kappa equals to 1 by R into L by A, or we can write L by A equals to kappa into R. Kappa, its conductivity 0.0112 into 55. If we calculate the value, then answer is 0.616 semi to the power minus 1. The next question is, for a 0.1 molar weak electrolyte, the conductivity is 0.009 Siemens per semi. The molar conductance at infinite dilution is 260 Siemens per semi square mole to the power minus 1. What is the value of degree of dissociation? What is the value of degree of dissociation means alpha. Degree of dissociation means alpha. We know alpha equals to lambda m by lambda naught m. Molar conductance at any concentration by molar conductance at infinite dilution. Okay, we know this value. This value is 260. Now we calculate the value of lambda m, molar conductance. We know molar conductance equals to kappa by C. Kappa means conductivity, 0.009 by concentration is concentration. Okay, concentration equals to 0.1 molar. That means 0.1 mole per liter. 0.1 mole per liter. We know 1 liter equals to 100 semi-cube. Now we can write 1 liter equals to 100 semi-cube. Okay, now 0.1 mole by liter. 1 liter equals to 100 semi-cube. Okay, now 0.1 by 100. So directly if we put it where 0.1 into 100. Now the value is what is the value? The value is the value is 90. Okay, so then alpha equals to 9 by 260. 9 by 260, that means the value is 0.3461. That is परसेंटेज में करना पड़ेगा, परसेंटेज मीन्स 100 से मल्टीप्लाई करना पड़ेगा. सो द वैल्यू इज 34 into 61%. So the answer is 34.61%. 34.61%.
To solve this question, what is the question? Molar conductance of NaCl minus molar conductance of NaNO3 at infinite dilution equals to 3.7 Siemens semi square per mole. Then what is the value of molar conductance of LiCl and molar conductance of LiNO3? So these are the option. So क्या करना होगा इसके लिए? पहले हम लोग इसको डिसोशिएट करेंगे. देखो क्या है, लैम्डा नॉट ऑफ NaCl equals to ionic conductivity of Na plus ionic conductivity of Cl minus. Okay, and lambda naught of NaNO3 equals to ionic conductivity of Na plus ionic conductivity of NO3 minus. Now Now lambda naught m माने that is molar conductivity of NaCl minus molar conductivity of NaNO3. अगर ये दो वैल्यू हम सब्सट्रैक्ट करेंगे तो मिलेगा हमको 3.7 साइमेन सेमी स्क्वायर मोल टू द पावर -1. ओके, सो we can write lambda naught m NaCl minus lambda naught m NaNO3, that is ionic conductivity of Na plus ionic conductivity of Cl minus ionic conductivity of Na plus ionic conductivity of NO3 minus. We can write lambda naught Cl minus lambda naught NO3 minus. So this value is given 3.7 Siemens semi square mole to the power -1. Now we have to calculate this value. Okay, lambda naught LiCl minus lambda naught LiNO3. If we dissociate this, so what happened? Ionic conductivity of Li plus ionic conductivity of Cl minus ionic conductivity of Li plus minus ionic conductivity of NO3 minus. So the value of lambda Cl minus lambda naught NO3 minus equals to 3.7. So the answer is B, 3.7 Siemens semi square mole to the power -1. The next question is, in 0.1 molar HCl or 0.1 molar NaCl solution, which will have greater transport number of Cl minus? Okay. First of all, we have to understand what is transport number. Transport number equals to fraction of total current carried by an ion. Okay, if transport number of a cation is high, then speed of ion is increases, that is conductivity, ionic conductivity is high. Okay, now you have to understand transport number of cation and transport number on anion equals to 1. And T minus equals to 1 minus T plus. Okay, now transport number increases, then speed of ion increases, and that is ionic conductivity of cation increases. So we can say transport number is directly proportional to ionic conductivity of cation. Now for HCl and NaCl, the conductivity of H plus is high than Na plus. So lambda H plus is high than lambda Na plus. Why?
The abnormally high molar conductivity of H plus can be explained on the basis of proton jump from one water molecule to another, which is very rapid. Okay, so positive charge transfer from one water molecule to another water molecule. In solution, the movement of H plus is higher than Na plus. So the ionic conductivity of H plus is higher than Na plus. As the ionic conductivity of H plus is higher than Na plus, so the transport number of H plus is high. We know T of H plus plus T of Cl minus equals to 1, and T of Cl minus equals to 1 minus T of H plus. As transport number of H plus is high, so the transport number of Cl minus is low. Okay, so the higher number of transport number is Cl minus in NaCl. So the answer of the question is NaCl.